The first question is, what type is the response variable? Is it categorical or quantitative? For our sample research question, the response or dependent variable is nicotine dependence, which is categorical. Next, we need to determine how many categories are in this response variable. Since nicotine dependence is coded 1 for yes or present and 0 for no or absent, we have 2 categories in the response variable. The next question to ask is, what type is the explanatory variable? The explanatory or independent variable is number of cigarettes smoked per month. As we saw in the demonstration of histograms, this is a quantitative variable. Since it won't be visually meaningful to examine a bar chart with a quantitative explanatory variable on the y-axis when our response variable is actually categorical, before we start to graph, it's important to bin our explanatory variable into categories. That is, in order to visualize the relationship that we're interested in, we need to add some data management that will allow us to construct a C2C or categorical to categorical bar chart.
Because by default the Pandas library often displays an abbreviated list of rows and columns from our data frame, and I know the number of values for num_sig_mo_est is fairly long, I'm going to add additional set option statements following the library import syntax that requests a display of the maximum number of rows and columns. The default in Python, you may have noticed, limits this display to a subset of the data frame, and so including display max columns or rows, comma, none, removes that limit and allows all rows and columns to be displayed. Now, after viewing the output, we can use the various cut functions from Python's Pandas library to group individuals in various ways. For example, into quartiles, roughly 4 equal groups in size. However, in this case, it seems a better decision might be to create more meaningful smoking groups based on specific quantities. Cigarette packs contain 20 cigarettes each. We're going to create a new variable that estimates the number of packs that each individual smokes per month, rather than the number of cigarettes. This could be a step closer to a categorical variable that's meaningful. The new variable is packs per month, and it is set equal to the number of cigarettes smoked per month, divided by 20. Then I add this new variable, packs per month, to a by group output statement so we can view this new frequency distribution. Packs per month is still a quantitative variable, but now we can more easily create groups based on number of packs smoked in a month. After examining the frequency distribution, I decide to create groupings that include those who've smoked less than 1 through 5 packs per month, 6 through 10 packs per month, 11 through 20, 21 through 30, and then 30 plus packs per month. To accomplish this, I add the following syntax to my program. When we add this new variable, pack category, to a describe statement, and then run the program, we can examine some basic descriptive statistics. But don't forget to let Python know that the new variable pack category should be treated as categorical. We can also examine the frequency distribution for this new pack category variable, representing packs of cigarettes smoked per month. Here we see the number of young adult smokers in each group. Back to our graphing decisions flowchart. Now that we've collapsed our explanatory quantitative variable, smoking, into categories, we're ready to make our C2C or category to category bar chart. When graphing the relationship between a categorical explanatory variable and a categorical response variable, we use the following code. This time, we use the catplot function from the Seaborn package. We name the categorical explanatory variable for the x-axis, here pack category, and also the response variable for the y-axis, tab 12 MDX. And define the data frame, here sub 2, where the variables can be found. Kind equals bar requests a bar chart, and CI equals none suppresses error bars, which you will learn more about in our statistical tools course. Again, with the xLabel function, we are able to label the x-axis, and with the ylabel function, the y-axis. Note that for a bivariate graph where our response variable is categorical, we will actually need to convert this categorical response variable back to numeric. This is because the bivariate graph displays a mean on the y-axis, which translates into the accurate proportion of individuals with nicotine dependence. Now, how's that possible? Remember that our categorical response variable should not have more than 2 categories or levels, and those 2 categories should be coded 0 and 1. 0 represents no or negative observations, and 1 represents yes or positive observations. In this format, requesting the mean of our categorical response variable actually gives us the proportion of ones or positive observations. However, as you saw from our work with the describe function, Python will not calculate a mean once a variable has been set to categorical. So I also need to add this syntax before requesting a bivariate graph, which transforms tab 12 MDX into a numeric variable. When I save and run this, I can examine our categorical by categorical bar chart. Pack category, our explanatory variable, is on the x-axis, and this is by the rate or proportion of nicotine-dependent individuals within each pack category along the y-axis. So you can see from the graph, among those smoking 1 to 5 packs per month, about 25% of those individuals are nicotine dependent. Among those smoking 6 to 10 packs a month, 50% are nicotine dependent. Among those smoking 11 to 20 packs a month, 58% are nicotine dependent. Among those smoking 21 to 30 packs per month, almost 70% are nicotine dependent. And among those smoking more than 30 packs a month, more than 70% are nicotine dependent, around 77%. We can also see that these rates form a pattern. That is, the more packs smoked per month, the higher the rate of nicotine dependence. So in a graphical way, we're already seeing that there seems to be a relationship between smoking and nicotine dependence as we hypothesized.
Looking at our graphing decisions chart, we can see the steps we've taken to generate a bivariate graph with a categorical response variable that has 2 categories and a quantitative explanatory variable. We also discussed how to convert the quantitative explanatory variable to a categorical variable, a step which must be taken for the purposes of visualizing the relationship. If our explanatory variable was originally categorical rather than quantitative, we could have skipped this step and just moved on to a categorical by categorical bar chart. What decisions need to be made if the response variable has more than 2 categories? In this case, we would need to collapse a response variable categories into 2 categories. To demonstrate this, we'll have to modify the research question. So let's modify the research question to look at the association between ethnicity and smoking stage. And we'll create a response variable that categorizes young adult smokers into 3 groups: non-daily smokers, daily smokers, and those with nicotine dependence.
These are the ethnic groups recorded in the NESARC codebook, along with the syntax that we can use to create a 3-category smoking stage variable. I am naming a new variable here, smoke group, creating the temporary variable called row, where I ask Python to return specific values, here 1 through 3, under certain conditions. If tab 12 MDX equals 1, if US freak MO equals 30, and a third group which includes the rest of our young adult smokers who are neither nicotine dependent nor daily smokers. Notice that I have used ELIF, known as else if, and also else. Using if in the first row draws on the whole sample. Else if, or ELIF, draws on what remains of the sample after the ones, that is, those with nicotine dependence, have been assigned a 1. And else, followed by a colon, literally puts everyone else in category 3, after the nicotine dependent and daily smokers have already been assigned values of 1 and 2.
This sample can be described with these 3 smoking categories. This univariate bar chart shows that about 50% of the young adults sampled are nicotine dependent, about 30% are daily smokers without nicotine dependence, and almost 17% are non-daily smokers. However, to examine a relationship between this variable as the response variable and another, we need to collapse this to only 2 categories. To do this, we need to make some decisions. Here are 2 perfectly reasonable decisions that we could make. We could examine the association between ethnicity and daily versus non-daily smokers, or we could examine the association between ethnicity and nicotine-dependent versus non-nicotine-dependent individuals, thereby collapsing across these categories in some way. In either case, some data management needs to be added to the program.
To collapse the response variable into daily versus non-daily smokers, we can use this syntax. If US Freak MO equals 30, that is, if the individual smokes 30 days a month, then return a 1 for the new variable daily. Else if, noted as ELIF, US Freak MO is not equal to 30, that is, not equal to smoking 30 days per month, then return a 0 for daily. Now we can again graph the relationship between our categorical explanatory variable ethnic group and this 2-level categorical response variable daily smoking. Remember, our categorical response variable should not have more than 2 categories or levels, and those 2 categories should be coded as 1 and 0, 0 representing no or negative and 1 representing yes or positive. In this format, requesting the mean of our categorical response variable actually gives us the proportion of ones or positive observations. Notice that the dummy codes for our ethnicity variable are not ordered on the x-axis, and because they are dummy codes, the graph is something difficult to interpret. You can rename categorical variable values for graphing, first by changing the variable format to categorical if you haven't already done so. Second, by giving the variable eth_2a new value labels with cat.rename_categorical. Here is our new graph. As you can see, the rate of daily smoking is somewhat lower among Native American and Hispanic young adults who have smoked in the past year compared to each of the other groups.
Because our response variable was categorical with more than 2 categories, we needed to collapse it into only 2 categories. And because our explanatory variable, ethnicity, was categorical, we created a categorical by categorical bar chart. Had our explanatory variable been quantitative, we would have needed to bin or collapse that variable into categories before creating the categorical by categorical bar chart.